So, what comes to mind when you think of the absolute most advanced machine on Earth? A supercomputer? Maybe a space shuttle? A particle accelerator? Well, the truth is, the most complex, highly engineered, and just breathtakingly efficient machine on the planet is literally sitting right where you are. Yeah, I'm talking about your own body.
Welcome to The Explainer. Today, we're not just looking at human biology as some textbook subject. We're going to look at it as an integrated, high-functioning super factory. The stats we're going to uncover are completely mind-blowing. And by the end of this, I promise, you're going to have a whole new appreciation for the incredible vessel you operate every single day.
Okay, let's dive straight into the schematic and map out the 5 functional departments we'll be exploring. We'll start with the Master Control Center, move down to the Ultimate Engine Room, check out the fuel processing plant, test the built-in sensor array, and finally look at the outer armor holding it all together.
Let's kick things off with Department 1, the Master Control Center, the brain.
Your brain is the ultimate boss of your body. It easily outpaces the most advanced supercomputers, effortlessly downloading, understanding, and reacting to just a massive volume of sensory data. And it's fascinating how its workload is distributed. The cerebrum hogs a massive 85% of your brain's volume. That's the part completely dedicated to thinking, learning, and controlling your muscles. The remaining 15%? Well, that's split between the cerebellum, which keeps you balanced so you don't just fall over, the brainstem, which runs background stuff like breathing and heart rate, and the tiny almond-shaped amygdala, which handles your emotions and memories.
Now here's a literal spark of genius for you. Your brain is electric, like truly electric. It generates between 12 and 25 watts of electricity at any given time. To put that into perspective, that is enough raw power to run a low-voltage LED light bulb. Imagine that. Your thoughts and movements are fueled by enough electrical current to literally light up a room. Oh, and here's a fun tip. Scientists have actually found that right after you exercise, your body produces chemicals that make this glowing supercomputer even more willing to learn.
Moving right along to Department 2, the Ultimate Engine Room, your heart and muscles.
So, your heart is basically a 4-chambered pump, and it pushes an astonishing 2,000 gallons of oxygen-rich blood through your circulatory system every single day. To truly grasp the scale of this engine room, just look at this number. Your heart beats about 100,000 times a day. Over an average lifetime, that translates to over 2.5 billion beats. And the crazy part? It does this entirely on its own, without you ever having to give it a second thought.
Connecting that incredible engine to the chassis are your muscles. You've got over 600 of them, and they're categorized into 3 types: smooth, cardiac, and skeletal. But how exactly do you upgrade this hardware? Well, when you lift something heavy, your muscles are put under stress and sustain these tiny damages we call microtears. In response, the damaged cells send out a distress signal, releasing inflammatory molecules called cytokines. These cytokines call in your immune system to repair the tears. And that repair process, that is exactly what makes your muscles bigger and stronger over time.
All right, heading down to Department 3, the fuel processing plant, digestion and waste management.
I mean, you've got to fuel the machine, right? This staggering biological assembly line transforms raw materials into vital nutrients, and the whole thing takes roughly 36 hours from start to finish. It all begins in the mouth. Fun fact, in a single year, you produce enough saliva to fill 2 medium-sized bathtubs. Let's track a piece of food on this journey. Let's imagine a little tourist named Gilbert the Grape. Gilbert drops into the mouth, navigates the crushing teeth, and slides right down the esophagus. Then he encounters a muscular valve that acts exactly like a TSA security checkpoint, granting him access into the stomach. If Gilbert didn't have some sort of theoretical, top-secret protective bubble, the intense stomach acid would instantly turn him into liquid mush.
But wait, how does our food actually move down the chute? I mean, it still works even if we're hanging upside down. It's all thanks to this process right here, peristalsis. The muscles in your esophageal walls squeeze tight right behind the food and relax right in front of it. It creates this continuous, rhythmic wave that reliably pushes everything deeper and deeper into your digestive factory. So, here's the real kicker. Once the food enters the small intestine, it enters a highly compact space. But if you were to take that tightly coiled tube and stretch it out, it's actually 20 feet long. That is literally as long as a giraffe is tall, packed right there into your abdomen. Inside, it's like a tropical resort made of bile from the liver to digest fats, along with trillions of helpful bacteria working overtime to extract vitamins and nutrients. Now, obviously, every processing plant is going to create liquid waste. That's managed by your kidneys, which act as high-tech filtration devices for your blood.
They pull out toxic waste and mix it with water to create urine, which then travels down to the bladder. And hey, quick safety warning for your biological machine. Holding your pee for too long on a regular basis can actually weaken your bladder muscles and lead to long-term complications. So when the machine says it's time to go, you go.
Welcome to Department 4, your built-in sensor array. Ears, nose, tongue, and teeth.
To actually navigate the world, our machine relies on a deeply interconnected network of data-gathering sensors. These process everything from the warning squeak of a cat to the amazing taste of cold ice cream. The specs on these sensors are just incredible. Up in your ear, sound funnels through the pinna, vibrates the eardrum, shakes 3 tiny bones called ossicles, and then creates liquid waves inside a snail-shaped tube called the cochlea. In your nose, a mucous membrane generates snot specifically to trap dirt and protect your lungs. And your tongue, it boasts anywhere between 3,000 and 10,000 taste buds hiding inside little bumps called papillae.
But here is where that integration becomes absolutely crucial. If you ever suffer from anosmia, which is the loss of the sense of smell, you'll quickly realize that your tongue really can't do its job alone. Taste and smell are completely interdependent. Without your nose actively sensing the aromas, your biological machine literally cannot properly experience the flavor of your food.
This whole setup brilliantly illustrates the specialized tools located right at our primary input port. As adults, we have a set of 32 teeth. Your 8 front incisors act like scissors to cleanly cut food, while your strong back molars act like heavy machinery to crush and grind it down. Oh, and here's a fun observational fact. Studies actually suggest that right-handed people naturally tend to chew their food on the right side of their mouths, and lefties chew on the left.
Speaking of the mouth, I want to show you just how vital your tongue's muscular flexibility is for basic communication. Go ahead. I challenge you right now. Try reading the text on this screen out loud without moving your tongue at all. I love the explainer. Pretty tough, right? That's because your tongue constantly has to narrow, move backward, and articulate perfectly to form almost every single consonant we speak.
Which brings us to our 5th and final functional department, the outer armor. Skin, hair, and nails. To protect the whole shebang, the master control center, the engine, the fuel plant, the sensors, the body wraps it all up in a highly dynamic, waterproof, temperature-controlled shield. This armor is your skin, and it is actually your body's largest organ. It covers over 18.5 square feet and makes up about 16% of your total body weight. It features 3 main layers: the continuously replacing outer epidermis, the middle dermis that houses your sweat glands and nerve endings, and the bottom hypodermis, which stores fat to keep the machine cushioned and warm. Enhancing that armor is a super versatile structural protein called keratin. Keratin is essentially the building block for both the dead cells that form your hair shafts and the hard protective surface of your nails. Actually, your nails are continuously being pushed outward by specialized cells, starting from a U-shaped matrix at the base, which features that cool little white half-moon shape known as the lunula. As for your hair, you have an estimated 100,000 strands of it just on the top of your head, acting as this protective, warm cushion for your skull. And look, if you ever look at your hairbrush and panic, don't. It's completely normal for this biological machine to shed anywhere from 50 to 100 strands a day as your follicles naturally cycle through their growth and rest phases.
Which brings us to our final thought for today. You are at the helm of a staggering feat of biological engineering. A machine with an electric brain, an unstoppable pump, a massive processing plant, intricate sensors, and constantly renewing armor. So the question is, what are you going to do with the most advanced machine on Earth today? Treat it well, feed it good fuel, let it get some sleep so it can repair those muscles, and of course, keep it eager to learn. Thanks so much for joining me on this explainer, and I'll catch you on the next one.